Hi everyone. So we just learned how to generate Pythagorean triples, and we were also just given a list in our handout of some common Pythagorean triples you might encounter. So now looking at our triangles, we can look at these numbers that were given and we can check to see if any of them fall into Pythagorean triples, which would save us a lot of time, so we could skip the Pythagorean theorem. So let's see, let's take a look at the lengths that we are yet to find the lengths of, or the parts of the triangle that we have yet to find the lengths of. So DB I don't know the length of yet, and BC here I don't know the length of either. Okay, so let's see here, 37, 35. Oh, that is actually part of a Pythagorean triple. So one of them is 35, 37, and 12. Aha. So I know that 12 is going to be this side here, BD. What about this length here? So I have one length that's 9 and another length that's 12. That doesn't sound familiar. However, if I scale this down to a similar triangle that is smaller, in fact, by a scale of 3, I can see here that it is similar to a triangle that has lengths 3, so 9 divided by 3 is 3, 12 divided by 3 is 4, and now it does look like a Pythagorean triple, 3, 4, and 5. So to scale this back to the bigger triangle, I'm going to multiply 5 by 3, and I will get 15 for this length here. Okay, so now my triangle is labeled, both of them are labeled, and I can begin to answer the questions. So part A asks, find the difference between the lengths ADC and ABC. So the length ADC consists of the line segment AD and the line segment DC. So AD, I can see here, is 37 meters long, and DC is 9 meters long. So adding those together, I get 46 meters. What about ABC? So it consists of the line segment AB and the line segment BC. AB is 35 meters, and BC, we just figured out, is 15 meters, which is a grand total of 50 meters. So we can easily figure out the difference by subtracting. It's 50 minus 46. It's 4 meters faster to go ADC than to go ABC. Okay, let's move on to part C, which asks us to find the distance AC. Okay, what is the distance AC? I'm just going to mark it here from A to C. Okay, so it's a diagonal line. How can we use the Pythagorean theorem if this doesn't lie on a right triangle? Well, we're going to have to create an imaginary one. So let's just pretend that we do have a right triangle here. Let's extend these two lines and make a right angle right here. So now we've got this triangle A. Let's call this point here, I'm going to call it E. Let's call this triangle AEC. And we're going to find its hypotenuse. So what lengths do I have here? From A to B, I've got 35, and now I have this triangle, this rectangle here that I've just created, DBEC. It's 9 meters on top, and I know that because it's a rectangle, this is also going to be 9 meters. And what about this side here, CE? Well, I've got this nice rectangle here. I know that DB is 12, so CE will also be 12. And now I have all the measurements I need in order to treat this as a right triangle. So I'm just going to draw a mini version of it here so we can deal with it more easily. So I want to know the length of this side. I know that this side here has length 12, and down here I've got 35 plus 9, which is 44. Oops. Okay, so does 12 and 44 and something else make a Pythagorean triple? You can use your new skills to check if it does, and I'll give you a second to do that. What you will find is that it does not. So we will have to perform the Pythagorean theorem. So we'll say 12 squared plus 44 squared is equal to, we'll call it c squared. So 12 squared is 144. 44 squared is a whopping 1,936. Don't know what c squared is yet. Adding these two together, we will get 2,080, and that's equal to c squared. Square rooting both sides, you will get an approximation of, so about 45.6 meters. So that is the length that we are looking for. This length here, AC, is approximately 45.6 meters. And looking at our triangle here, that probably makes logical sense.